Hello there, and welcome back. What we have in this picture here, we have the sides of a cooling tower that are modeled by a hyperbola, and we want to write the equation of this hyperbola given the dimensions that are shown in the figure here. And we're also going to estimate the width of the base of the cooling tower. So things to remember about a hyperbola is that the points closest to the center of the hyperbola are the vertices of the hyperbola. So the side labeled 60 meters here, we're going to say that the midpoint of that line segment there is the origin, 0, 0. So we're going to position the center of the hyperbola at the origin, which remember has the simplest equation. And that means this point right here would be 30, 0, and this point over here would be negative 30, 0. Now that means that the equation of the hyperbola would have to reflect vertices that are on a horizontal line with the center in the middle. So that means we're going to use the equation x squared over a squared minus y squared over b squared equals 1. And now we know that a is 30 because the vertex is 30 units away from the center. So that means a is 30. So we have x squared over, now 30 squared is 900, minus y squared over something we don't know yet equals 1. So now it's our mission to figure out the value of b squared. So what other dimensions on the figure that are given here are going to give us that information? Well, we don't have foci, so we can't use the relationship a squared plus b squared equals c squared. But we do know that the top of the tower is 72 meters wide. And that's at a height of 79.6 meters from where we position the center. So that means that this point right here is 36, 79.6. And that means the one on the left-hand side is negative 36, 79.6. We only need 1 point. Because if I substitute an x and a y into the equation, for that x and y to satisfy the equation, we're going to be able to find the value of b squared that satisfies the equation. So x being 36, we have 36 squared over 900 minus 79.6 squared over b squared equals 1. Now we can solve this equation for b squared. So 36 squared over 900, I'm going to use the calculator to help us out here. So we have 36 squared over 900 is 1.44. So 1.44 minus 79.6 squared is 6336.16. And that's over b squared equals 1. So what I'm going to do is I'm going to subtract 1 from both sides, and I'm going to add the 6336.16 over b squared to the other side. So we're going to have 0.44 equals 6336.16 over b squared. And now multiply both sides by b squared, and then divide both sides by 0.44. We have b squared equals 6336.16 divided by 0.44. And that means b squared is approximately, let's see, 6336.16 divided by 0.44. We do get an elongated decimal there. Now, since we're potentially using this value of b squared in more calculations, I'm going to use all the decimal places that are, well, I'm going to use the first 4 that are presented there. So 14,400.3636. So that means our equation is x squared over 900 minus y squared over 14,400.3636 equals 1. So there's the equation of our hyperbola. Now what we want to do is use the given information to estimate the width of the base. So that means this down here. Now, since the topmost coordinate, the topmost y coordinate is 79.6, and the entire tower is 179.6 meters tall. That means that these points here have x coordinate unknown, but y coordinate negative 100, and this is a negative x, negative 100. So if I find the value of x, I know the width of the base, because all I have to do then is double it. Okay, x gives me the distance from the center to one of the endpoints. So if I substitute y equals negative 100, so I'm going to write here width of base. So we have x squared over 900 minus negative 100 squared over that number. And now it becomes a mission of solving for x. Now what we're going to do is, okay, I'm going to calculate negative 100 squared divided by 14,400.3636. So that's that number. So we have x squared over 900 minus 0.6944269,102. So here's how this is going to go. We're going to add the 0.69 number to both sides, and then we're going to multiply both sides by 900 to find x squared. So that means x squared is approximately equal to, so I'm going to take this number here and I'm going to add 1 to it, and then multiply that by 900. So that is the value of x squared, 1524.984219. And that means x is approximately equal to, so I'm going to take the square root of that answer. And that is 39.0510, etc. You see the number there on the calculator. And then the width of the base is twice that amount, so I'm going to multiply that by 2. And now at this point, we'll round our final answer to the nearest tenth. So the width is approximately 78.1 meters wide at the base. So there's how we can use a hyperbola to model real-life situations.